a collection of Stuart engines and some other nice things. This one is part 6, completing the bushing of the flywheel and shortening the crankshaft. Then filling the second hole in the flywheel casting using JB Weld. Reassembling the parts, followed by running the engine. In the last episode, I showed how I made a mandrel and then using some Loctite 603 secured the flywheel to this mandrel. This next part is very important. I'm checking the size of the crankshaft, because I need a hole in the centre of the mandrel exactly the same size as the crankshaft. And I'm not going to get this by using a drill. This is one imperial drill size less than the final size I need it to be. And for the final size I will ream the hole using a 7/16 reamer. I don't need to drill all the way through the mandrel, but I need to drill through it sufficiently to get past the other end of the flywheel. I'm using quite a lot of cutting lubricant in this episode because I do not want this part to get hot. After drilling the hole, it was time to use the reamer. It's very important to run the lathe slowly for this job. It's in back gear. And strangely enough, on the video it looks much faster than it really was. And also on the video it looks like it's running backwards, but believe me, it isn't. I gently pushed the reamer all the way into the hole. And now, with a bit of luck, I should have a hole in the mandrel, which is a perfect 7/16 of an inch diameter. Time to test it. I fitted the crankshaft in place and it's a really good fit, which is just what I want. Now it's time to saw the mandrel so that the flywheel can be removed from it. You mustn't do it like this for a variety of different reasons. The first one is it's very easy for the saw to catch the flywheel. The second reason is if the saw goes all the way through, the flywheel will fall off onto the bed of the lathe and could be damaged. Worse than that, if the saw breaks through, the saw blade could damage the bed of the lathe. Not good. How do I know about things like this? Well, in the past, I've done all these things when I was young and stupid. I removed the mandrel from the chuck, clamped the mandrel in my bench vise, and that's how I cut it. And now I'm cleaning up the end, which is now a bush. Any experts who shouldn't be watching this tutorial for beginners anyway, please don't bother telling me that the flywheel is not running true. I am aware of that. And the reason for it is simple. I'm going to make a special video called The Problem with Turning Flywheels. Back to this job, and I'm really pleased with the finish I got from this reamer. And I'm pleased to say that the crankshaft is quite a tight piston fit. The next job was difficult. I need to drill and thread one of the holes to clamp the flywheel onto the crankshaft. The threads in the cast iron weren't very good anyway. I made a mess of the one at the other side by using my large drilling machine with a tapping size drill for 2BA. Luckily I get a second chance with this, and I drilled a pilot hole 1/8 of an inch in diameter first. Threading this hole was very difficult. It goes through the steel collar at an angle, and as the tap breaks through, it really puts a lot of strain on it, so being very careful was the order of the day. In this clip you can see just how much pressure I'm putting on the tap and how many times I wind it backwards. Once I'd successfully threaded the hole, I filled up the one at the other side using JB Weld, and that's exactly what I'm doing in this clip. Once the JB Weld has cured, I'll put the flywheel in the chuck and very slightly remachine this end to clean off the surplus JB Weld. This is all I can do with the flywheel for the moment until the JB Weld has cured. What I'm doing here is getting ready to shorten the crankshaft and marking the length that I need it to be. To obtain the length of the crankshaft, before I applied the JB Weld to the flywheel as shown, I took the crankshaft and the flywheel down to my second workshop, which is built onto the house and therefore warm. I loosely assembled the parts and I made a mark on the crankshaft, as you can see here. This is going to be the final length. And here, with one end held in the chuck, I'm parting off the finished crankshaft. On small home workshop lathes, parting off can be a problem. I do most of my parting off in either the Boxford lathe or the Smart & Brown. Brass and mild steel is quite simple to part off, but silver steel is a good bit harder. If you look at the end where I snapped the part off, You can see that the brake looks to be quite crystalline. To face the end of the crankshaft, and bear in mind this is the end that doesn't have the crank web fitted to it, I use my Smart & Brown lathe, which is fitted with a 4-jaw self-centering chuck, and because of the spindle bore diameter I could fit the crankshaft into the chuck with the crank web on the inside. Then, just for decorative purposes, I centre drilled the end. Once I'd finished that, I cleaned off all the swarf from the crank web. And here is the finished crankshaft looking at the crank web end. Really, it shouldn't have a bolt in there, it needs a taper pin, but I think for the moment the small bolt Loctited into the hole will suffice. If the crank web works loose, I will then fit a taper pin. It's reassembly time. Before you see it, I will give you advance warning. This is the first coat of a colour of paint that is not Stuart green. This is Buffer Beam Red. Don't ask me why, but I do like red flywheels on beam engines. I'm going to have to make a base for this engine because the pedestal just sits on the bench, and it's actually a fraction too long. During the assembly process I'm using plenty of oil, and I do intend to remachine the end of the crank pin, and I'll use a better method for refitting it which won't mark the steel. Earlier in this video I mentioned that I'd purposely left the flywheel out of true. I did this on purpose. It's not very much out of true, only slightly, because the way that I made the bush for the flywheel was not the perfect method really. But it will allow me to make a video that I've been wanting to make for quite a while, covering the subject of chattering when turning in a lathe. This is still the first coat of paint on the flywheel, and I think for one coat over green it's looking okay, but with another coat it will be miles better. With the crank pin secured to the crank web, I now need to set the timing. And then it was time to oil the engine because I'm going to run it, which will be the final part of this video. As you can see, I'm applying a copious amount of oil. I want plenty of oil to wash around the parts and keep them clean. I fitted a 2BA grub screw into the hole to secure the flywheel to the crankshaft, but I wasn't pleased with it. Then I tried a 2BA stainless steel bolt, and I was less pleased with that. I think I will fit an M6 grub screw to make sure that the flywheel is securely fixed to the shaft. I cut up an old envelope because I need some packing underneath the engine to level it up. And that concludes this episode. There's still a bit more to do when I make the special video about machining flywheels and the chattering phenomenon. But that's it for now. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. I'll leave the engine running to the end of the video. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.